Let us look at how to analyze the TLR4 and NOT2 signaling data that we got in our experiment. So in this video, we're going to get the answers of some of the questions like, where are our readings? Now, all the readings related to this experiment can be found in the class Google spreadsheet, and there is a tab called as the Innate Immune Signaling Lab, and that's the spreadsheet where all the readings are, and we'll look at that in just a minute. We will also answer the question of what readings to analyze. And so for that, we will be analyzing the readings from both the TLR4 and the NOT2 cell line, but we will look at only those readings that correspond to the concentrations of LPS and MDP that your group used. We will also address the question on what all analysis do we have to do, and we will look at how to calculate the means, the standard deviations, and the p-values for the data that we obtained. And finally, how do we do all of this? So let's go ahead and have a look. As mentioned, all the data is in the shared Google spreadsheet. And here we can see the layout of the plate. And so at the top, we had the NOT2 cell line readings, and at the bottom, we have the TLR4 cell line readings. And the actual readings are shown in this table below. Okay, and so let us say that I went ahead and my group was responsible for the 1 microgram per ml LPS and MDP. And let us say that my group did the NOT2 cell line. So the readings that I am interested in are going to be right here. But in addition to the NOT2 cell line, I also will be analyzing the data from the TLR4 cell line. So just to go ahead and show these better, here are the two sets of conditions, and the actual readings that I'm going to be using are shown right here and here. So let's start analyzing this. So to make things easy, I'm going to first go ahead and copy the conditions that I'm going to analyze. So I'm going to be analyzing the 1 microgram per ml for the NOT2 and the TLR4. So I've copied my conditions, and then in Excel, I'm going to go ahead and paste those conditions. And now let's get the actual readings for the NOT2 cell line. And so when we go back to our spreadsheet, those readings are right here. So I'm going to go ahead and copy and paste those readings right there. And I'm going to give some space, and I'll go ahead and put the TLR4 cell line readings here. And so going back to the spreadsheet, this is where the readings for the TLR4 cell line are that correspond to that 1 microgram per ml of LPS and MDP. So now I have all my readings. If it bothers you that some of your titles are missing or look incomplete, then you can go ahead and wrap the text around so that way you can see all of them. Now to do the actual analysis, let's first find the central tendency, which in this case is going to be the mean. To find the mean, Excel uses the code average. So I'm going to go ahead and find the average for each condition. Now if you have trouble keeping track of your conditions, then you can go ahead and actually form these boxes around them. Like here's for the Heg blue reagent, here's for water, here's for LPS, and here's for MDP. Now going back to the average, I found the average or the mean value for the Heg blue reagent condition. I can do the same thing for the water, where I'll go ahead and type in the actual formula, select the readings, and I get my average. Or I can just go ahead and copy it across, but you have to remember that some of these numbers are actually not the right mean values. So you have to remove all the mean values that are incorrect. Now, how do you know whether you have the right mean value? if you click on the cell and you look at the actual formula, it tells you that it's finding the mean, and it even highlights it on the spreadsheet of these appropriate cells. And as long as they belong to the same condition and the same cell line, then we're good to go. After finding the average, we can also find the standard deviation. Well, that's not where it's supposed to go. So let's go ahead and tell it the actual values. There, that should correct it. Now let's go back and do our standard deviation. There are different types of standard deviation options that are available. I just use the simplest one, which is STDEV. And then go ahead and select those readings that you use to find the average. Once again, I'm going to move it across and remove all the readings that are not relevant. Now that we've finished everything for the NOD2 cell lines, so we found out our means, we found out the standard deviation, which is a measure of dispersion. Let's do the same thing for the TLR4 cell line. And we are first finding out the means, and we're doing that for all 4 conditions and removing any readings that are not relevant. And then we will find our measure of dispersion, which is the standard deviation. Please remember, you're going to use only those readings that belong to a same group or same condition and the same cell line. Now that we have the means and standard deviations for both the NOD2 and the TLR4 cell line, we're ready to make our graph. So I'm going to choose a column graph, and here we have a nice blank chart. So I will select the data that I want. Now I want both the NOD2 and the TLR4 cell line in my graph. And so what I'm going to do is I'm going to tell it that I want a series. And I'm going to look at it. We can do it in multiple ways, but the one that I'm going to choose is I'm going to go ahead and list every condition that was chosen. So let's try this again. And so the Y values here are going to be the average for the NOD2 cell line and the average for the Hegg-Blue media for the TLR4 cell line. And as you can see, these two readings, they're not right next to each other, so you can't click and drag. So if you're using a Mac, then you should click on the first value, then click or hit the command button and keep it pressed down as you click on the second value, and then only release. If you are using a PC, then instead of the command button, you will use the control button on your keyboard. Once we're done with that, we can now go ahead and choose the water condition. And here also we will use the average water for the NOD2 cell line. Click the command or the control button and then do the same thing for the TLR4 cell line. We can go ahead and add the next one, which is LPS. And so once again, find the average reading for the NOD2 as well as the TLR4. And then finally, we're ready for our last one, which is MDP. And we're able to go ahead and choose the average readings for both cell lines. We're now ready for the horizontal axis or the x-axis, and for that, that's going to be our 2 cell lines. Now once this is done, we are ready to hit OK, and now we are able to see both our NOD2 cell line readings and our TLR4 cell line readings. We now are going to show the dispersion in the form of error bars, so we will click on each condition go to the Add Chart element and find error bars. Now my Excel doesn't allow me to customize, so I'm just going to go ahead and choose some random error bar and then click on the actual error bar, and when I double click on it, it now opens the format. So in this case, I can actually go ahead and choose custom, which is what I do need. And so we will specify the value, and we are interested in the positive values. So I will find the standard deviation readings for my NOD 2 and my TLR4 cell line and say OK. And that should update the error bar. We have to do the same thing for every condition. So since my Excel does not allow me to choose a custom, I have to go through this little roundabout route. If your Excel provides you the custom option in that Add Chart element, then please do go ahead and use that, because that's a faster way than what I'm having to do. So we're now adding the error bars for our LPS. And we have only one more left, which is the MDP. Okay, so now that we have all our readings, we can go ahead and start ensuring that we can put axis titles. So for the vertical axis, what we're looking at is the absorbance. And whenever we have an absorbance, we should also specify the wavelengths, which in this case was 594 nanometers. We don't have to specify the x-axis because we can already see that it is labeled with the NOD 2 and the TLR4 cell line. We do have grid lines and we don't need grid lines, so you can keep it or you can click on any one of the grid lines and all of them will get highlighted and you can go ahead and delete that. We can see the x-axis line, but there is no line that represents the y-axis. So to add a line, click on any of the values of the y-axis. If you double click on that, you will have this option open. And in there, go to the paint bucket. And at the paint bucket, go for line and say solid line. And you can have a variety of colors to choose from. I'm just going to keep it simple and make it black. And I will go ahead and match the x-axis to that, so that way now we can actually see both lines pretty distinctly. You don't need to have a chart title, but if you do want to have one, you can label it appropriately. I'm just going to go ahead and delete it. So now we have our graph, but the last thing we need to do is find the p-values. For the p-values, we're going to find the p-values for every cell line. So let's just do for the NOD cell line. Now in this case, what we're going to do is we have 4 conditions and you can't see the legend. So if you can't see the legend, then you may have to go ahead and add the legend. And so to do that, just select on your chart, and when you go to chart design, you should be able to find one that says legend, and you can have it wherever you want. So there are 4 conditions for the NOD 2 cell line. That means we have to use an ANOVA. Now not all Excel comes inbuilt with ANOVA, but all Excel does allow us to do t-tests. So what we're going to do is we will simply do multiple t-tests. So we will go ahead and do a t-test. And a t-test is between 2 groups. Please ensure that you use water and compare water with LPS and MDP. So here we'll do LPS. It's going to be only for the NOD 2 cell line. And so the way we will go ahead and analyze it is to do a t-test, you put the equal sign and type t-test. So once you have typed t-test, put a parentheses, and you can see there are 4 variables that show up: array 1, array 2, tails, and type. Right now, array 1 is bolded or highlighted. Arrays basically are the readings. So array 1 will be all the readings for the not to sell line that correspond to water. And so you have to click and drag. In this case, the readings have to be next to one another. They cannot be far apart. Once you've selected your readings, you have to put a comma. If you don't put the comma, you cannot proceed. So please put the comma, and now we can see array 2 has become highlighted. So array 2 will be the next group's reading. And in this case, we're looking at the not to sell line and looking at the LPS readings. So we will click and drag to select the LPS readings. Then comes put the comma, and you have to choose the tails. The number 1 is a 1-tail distribution, while the number 2 is a 2-tail distribution. The tails involve which direction you are interested in. Are we interested in an increase in readings or in a decrease of readings, or both? For simplicity's sake, we will simply say we're doing a 2-tail distribution. So we'll add the number 2 and then put a comma, and then we need to choose the type. We're not doing a paired t-test because there's no type of pairing among the readings between water and LPS. But we will assume that our samples show equal variance. So we're going to go ahead and choose number 2. And we'll close the parentheses because now after we choose the type, there's no other parameter to choose. So once we close the parentheses and hit enter, this number that we get is the actual p-value. And so if this is less than 0.05, it means it is statistically significant. If it is more than 0.05, then that means that it is not significant. Similarly, let's do a t-test of water versus MDP for the not to sell line. So we will go ahead and choose the water readings. We will multiply it or include, not multiply, but now choose the LPS readings. We will do 2 tails and we will do equal variance. And now we get our p-value. And so we can decide if there is a statistically significant difference. Similar analyses should be done with the TLR4 cell line. And so in this case, I'll just do one of them where we do water versus LPS. Or in this case, let me just go ahead and do MDP and let's see what we get. So put the equation, and now we will choose the water readings, and then we'll go ahead and choose the MDP readings, choose the 2 tails and the 2 type, and now we get our p-value. Similarly, do t-test of water versus LPS, and whatever number you find will be the p-value. So this way we are able to determine the p-values to know if there is a statistically significant difference. So with this, we come to the end of our data analysis. I do want to point out that under ideal circumstances, we shouldn't be doing t-tests. We should be doing an ANOVA. There are plugins available where you can add ANOVA to Excel, but since everybody may not have that, we went ahead and did a t-test, which is not the right thing to do, but at least it gives you practice on how to do a t-test. So that's it for now.